Hello, my name is Anthony, and I'm the project lead for the GamesCrafters Puzzles team, Spring 2021. It's been an exciting online semester, and the Puzzles team is excited to demonstrate what we have accomplished. Let's begin by introducing what a puzzle is. A puzzle can be defined as a one-player game, where the goal of the puzzle is simply to reach an end state. In Towers of Hanoi, for instance, the goal here is to move discs from rod to rod until all the discs have ended in the rightmost rod. This semester, we're focusing on extending Gamesman puzzles into the GamesCrafters online GUI, Gamesman Uni. Here, we introduced a new tab for puzzles. Look how many puzzles there are available to play. Amazing. Let's check out one of the puzzles that we can play. Clicking on a specific block leads us to a specialized puzzles page, like Towers of Hanoi. Similar to how games are played, we are able to select and execute moves on the board, as well as keep track of our visual value history. Here, we can check which moves have produced the best results, or which moves have led to mistakes. Using the Universal Web API Standard, or UWAPI, we are able to generalize some puzzles to produce automatic GUIs. Here's a variant of the 16 puzzle, the 9 puzzle. The goal of this puzzle is to rearrange the numbers in the grid so that the entire square is in order, row by row. We can click on these arrows to move the pieces, and using our move value software, this will allow us to determine which moves we need to make to reach the end state. The next part of this video will be introducing two members of the puzzles team and showing their work with Gamesman Uni and the automatic GUIs. They have worked super hard to present you with their results. So sit back, relax, and enjoy.
Hello everyone, my name is Mark and I'm a member of the Puzzles team in the GamesCrafters research group. As you might know already, the Puzzles team works on single-player games that are non-probabilistic and where all information is known. Previously, all games that we added to the system had to be played using a terminal interface. For example, as you can see on the screen, this is how we would play Peg Solitaire. In Peg Solitaire, you need to jump over an adjacent peg with a peg into an empty space. Once jumping over a peg, it is removed from the board. The goal of the game is to have one peg standing at the end. So here, as you can see on the terminal interface, we'd play the game by typing in moves like D peg to A peg. And as you can see, the B peg was removed. You want to continue until all pegs are removed from the board, given you play properly. This takes a while, but I'll ignore the nitty-gritties for now. While this terminal interface is nice, it is not very accessible. That is why this semester I worked on adding graphic interfaces for puzzle games using UWAPI, a universal web API. I specifically added GUIs for Peg Solitaire, Chair Hopping, otherwise known as Leapfrog, and Hop and Drop. I will briefly go over each of these games. As you can see on the screen now, this is Gamesman Uni. This Gamesman Uni was developed by GamesCrafters and is used to play and solve games and puzzles. Here, you can see all the puzzles we currently have in the system. I'll start by showing chair hopping. Here's the variant of chair hopping. In chair hopping, the objective is to get all X's to the right side and all O's to the left side. As you can see, X's can only move right and O's can only move left. You can either move into an adjacent space or jump over an opposite piece. So let's try it out. We're gonna move that guy over. Let's hop. We'll shimmy this way, hop over. Let's move this way, hop, 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 and we're hop. As you can see, we failed and we did not properly get all the O's and X's to each side, but let's retry it. One of the cool things about Gamesman Uni and the graphic interface is that we can find what moves are actually the best. So once we turn on the hint, we can see the green arrows correspond to a winning move and the red arrows correspond to a losing move. So if we follow all of the hints, let's see what we get. This can also be done using the terminal interface, but again, it is not as accessible as Gamesman Uni and a GUI that we have implemented here. And I think we're almost there. A few more clicks. As you can see, once you get the hang of this game, it's a simple pattern, but nonetheless, a few more moves, and we have solved the game successfully. The next game we'll look at that I implemented this semester with a graphic interface is Hop and Drop. For Hop and Drop, we have 3 available maps. Let's play map 2 as it is the medium difficulty. In this game, the goal is to clear all the tiles and end up on the X. The letter that is uppercase is your current position. B represents a tile with 2 health, A tile with 1 health, C a tile with 3 health, etc. And so you want to clear all the tiles and then end up on the X. Let's try it without the hints, so make it a little bit more difficult for us. Say we go up, so now we're on this tile. We shimmy over. You notice how the B is now A, because once you jump on a tile, it removes 1 health from it. We can go over here. Let's go this way. We'll go right, we'll go up, and we'll go back around. I've played this one a few times, so I might know the pattern. But yeah, this is the GUI for Hop and Drop. You can begin to other maps as well, as you can see here. I won't dive into it now, but this is a more complicated one where you have a tile with 3 health. But yeah, it's very fun and appealing to play. The final GUI I'll go over today is Peg Solitaire. This is one we've been working on for a while, and I showed you the terminal interface for. Here, it's simply embedded into a right triangle in a square instead of the triangle format you saw in the TUI. But we can try it again. Same game function, same idea. Let's see if we can solve this one. And here, didn't seem to work out this time. Thank God we can show hints though. And we can try one more time. Let's go here, here. As you can see, there's several possible winning moves for each game state, which is pretty exciting. But as you progress, there's more and more dangerous moves, so you got to be careful of those. And we successfully solved it. Well, I would like to thank you for your attention. And please feel free to explore all the fun new GUIs we have for the puzzles. And have a great day. I hope you enjoy playing more puzzles.
Hi, my name is Mia and I am part of the puzzles team. This semester I decided to implement the N Queens puzzle, which is basically a puzzle where you try to place N queens in an N by N chessboard in such a way that the N queens don't attack each other. This means that no queen can be in the same row, column, or diagonal as any other queen on the board. The puzzle was originally thought of for 8 queens in an 8 by 8 chessboard, but it can be played with a minimum of 4 queens in a 4 by 4 chessboard and up any number of queens you want to play. So in the screen right now, I have the 4 by 4 chessboard. So we're going to try to solve the 4 queens puzzle. Right now we have the 4 queens in the same row, which is invalid. So we want to move at least 3 of the queens in order to solve this puzzle. The remoteness of a game is basically how close you are to solving the game, or in this case, the puzzle. So right now we have the remoteness 3, which means that we can solve this puzzle in 3 moves. The green arrows represent a decrease in remoteness, so we are getting closer to solving the puzzle. If it's yellow, it means that we're neither getting closer or farther away from solving it, so the remoteness is staying the same. And if the arrow is red, it means that our remoteness is increasing, so we're getting farther away or increasing our number of moves in order to solve the puzzle. So we're gonna start by moving in a direction that is green. So right now we have this queen here and all of these queens are attacking each other and this queen is attacking this queen. So we're gonna move this one. So as you can see right now, we have made 2 moves and in 1 move, we can solve this puzzle, which would be by doing this, but I'm gonna show what happens. So imagine we are not thinking properly and we think that, oh, maybe if I move this queen here, it will solve it, right? And then you realize, oh no, it's attacking this queen and this queen, so this is not a valid. So you can actually undo that move and then do the correct move, and then now you have solved the puzzle because you have 0 remoteness and yeah, no moves left. So we have solved this puzzle. This is a working project. So right now, as you can see, we started with the 4 queens on the board, but now I am trying to implement this puzzle by having the 4 queens or n queens, depending on the variant you're playing, outside of the puzzle, and then the player clicks on the position of the board they want to place the queen at. So that's what I'm currently working